This lesson focuses on igneous rocks, one of our three kinds of rocks we are studying. Let's first review what is a rock. Well, we got to ask our is question. So is it a mixture of minerals, organic matter, and other materials? If it is a mixture of all these different things, then it has to be a rock, not a mineral. We also know rocks are classified by how they are formed, where they are made in the earth, and how they are made. And the three types of rocks that we're studying are igneous, sedimentary, and metamorphic. So when we talk about igneous rocks, I always try to think of ignite. And I know ignite is to start a fire. So igneous rocks are hot. They start from something that is fire-like. We see some good examples here of igneous rocks. So now let's delve in a little deeper and learn about them. So igneous rocks either come from ignited, very hot magma, which is inside the earth, or ignited or really, really hot lava, which is outside the earth. Magma and lava are both molten rock. They're just in different places. So the magma would cool very, very slowly below the Earth's surface. So it would rise up and it would get cooler as it was near the surface, but it would cool very, very slowly. Lava, on the other hand, exits the Earth. Okay, it comes out of the Earth and it's cooling above the surface, so it's going to cool a lot quicker than magma inside the Earth. So we know igneous rocks are formed from either lava or magma. Just like we classify other rocks, we classify igneous rocks by their visible grain size. So the grain is really what we're seeing. So the one on the left is a coarse grain. The grains are much bigger. It means there's big grains. It means it cooled a lot slower. It had a long time for these grains to grow. So we know if it's cooling slower, it probably cooled from magma inside the Earth. And on the right, we have some fine grains. They're very small. You can hardly see any grains at all. And we know this is cooled faster because they had a faster time to grow, or not very much time to grow at all. So we know that probably happened outside the Earth because it cooled much faster. So really, how fast is fast and how slow is slow? So an extrusive, that means exiting the Earth, is lava. And the cooling time is anywhere between seconds or months, depending on a lot of the factors in the environment at the time of the eruption. If it's the middle of summer somewhere and it erupts, it's going to take a little longer. But if it's in the middle of winter when it's already, we'll say 30 degrees out, we know it's going to cool much faster. Intrusive, inside the Earth, magma, on the other hand, can take thousands and thousands of years. It takes a long, long time to grow. So they're going to have a medium to large grain. So we've talked a little bit about intrusive and extrusive. Intrusive is inside the Earth, which means it's magma. It's cooling down slowly, so it's going to have large grains. Extrusive, on the other hand, is going to cool outside the Earth. It's cooling a lot faster, so it's going to have really small grains. Sometimes we don't even see any grains at all. So the faster it cools, the smaller the grain. The slower it cools, the larger the grains. So here's a great example. How are they the same? How are they different? Well, they were both formed from some molten rock, but some were formed inside the Earth from magma. They took a long time to cool. So this diorite took a much longer time to cool than the gabbro. Basalt, these other ones, formed outside, extrusive. So while they both formed from magma or lava, which is molten rock, they formed very differently because of the length of the time it took to cool and where they were when they started cooling.